Hello everyone. So now we are going to see about elementary operation, means transformation of a matrix. This concept is very much important in the last exercise, and in this we are going to little bit change our concepts. Like right now what we were doing, it is something different from all the time. So in this topic you need to concentrate very much properly in this, and here there are lots of method. In previous topics what was happening is there exists a unique method, means only one method, that's it, the answer you will get. But here it is not like that way. It is a very important thing over here, keep in mind. Now you have to think and answer, it will be there. So here everyone listen to me very carefully. In this, the first topic is elementary operation, means transformation of a matrix. Now, actually by looking at this, you see here three topics are there, means 3 points are there, but actually there are 6 points. How? First is applied with row. First, if first point is applicable with row, then it is also applicable with column. If second point is applicable with column, it is also applicable with row. And third point, it is applicable with row, then it is also applicable with column. So now what you have to do, I am telling it first one. Suppose you have a matrix. Now what we are going to do is that in one matrix we can interchange any two rows or two columns. Very important point, the interchange of any two rows or two columns means in one matrix we can interchange any row. But how? See, suppose there is a matrix A which is given like this way: 1 2 1 minus 1 root 3 1 5 6 7. Now here suppose we want to interchange row 1 with row 2, means row 1 is 1 2 1, it will be here row 2 1 2, here row 2 is minus 1 3 1, that row will be shifted towards first, that is minus 1 3 1. So here what we have done, first row is made to shift to second, and second row is made to shift with first. So here it's the same thing we can do with the column also. So what you are supposed to do, that in a matrix of any order you can interchange any two rows or any two columns, but you have to use this symbol. Row 1 is shifted to row 2 and row 2 is shifted to row 1. So after applying this property, it is shifted to, so this matrix and this matrix both we can consider they are same. What we have done, just shifted the first row to the second row and shifted from the second row to the first. This part can be applied to the column also. We can shift first column to second, and we can also shift second column to first. I hope so it is clear. Now the second thing, the second point, that is the multiplication of the elements of any row or column by a non-zero number. Suppose you want to multiply all the elements of any row. अगर आपको ये जो रो है 1 2 and 1, ये रो फर्स्ट है, फर्स्ट रो को कोई भी नंबर से मल्टीप्लाई करना है, बट वो नंबर नॉन ज़ीरो होना चाहिए. सो हियर सपोज यू वांट टू मल्टीप्लाई रो 1 with any non-zero number, then you can multiply. Now let us take an example. We are multiplying here, this is one row, first row, second row, first column, second column and third column. What we are doing over here, let us consider one matrix B. Now in this matrix, column 3 is 1 and 1. This is the column 3. Column 3 we are multiplying by 1 by 7. So this element of column 3, if we multiply by 1 by 7, then 1 into 1 by 7 is 1 by 7. Here also same way, 1 1 into 1 by 7 is 1 by 7. Here you can note one thing, all other elements are as it is. See, 1 and 1, 2 and 2, minus 1, root 3, root 3. But column 3, so this column 3 is only multiplied with 1 by 7. You can multiply with any of the number which is a non-zero. You can multiply any column or any row. It's all the elements you can multiply with a non-zero number. I hope so it is clear. The same thing is applied to the row also. Suppose you want to multiply number 3 to the first row, then you can multiply 1 into 3 is 3, 2 into 3 is 6, and 1 into 3 is 3. So here 3, 6 and 3 will be the, over here it will come, and this second row will be remaining same. Now third thing. Now in third point you need to be little bit careful over here. See, by looking at this you find it is very means by if I will read this, then the addition of elements of any row or column, the corresponding elements of any other row or column multiplied by a non-zero number. मतलब कि अगर ये रो, for example consider this matrix C. Now in this matrix C, what you want to do, that is, suppose you want to get 0 over here. Suppose we are solving any particular sum, और वो sum में अगर हमें यहाँ पे ये जो element 2 है उसे 0 बनाना है, then we will take the help of this third one. How? See, this is row 2. Okay, अब उसे आप column 1 भी consider कर सकते हो, this 1 and 2, but we are considering row over here. So in this row elements are, second row elements are 2 and minus 2. Now here this 2, and here if we subtract from this row, then also we are not getting 0. 2 minus 1 is 1. But अगर आप लोग ध्यान से देखो कि अगर ये रो को पहले आप 2 से मल्टीप्लाई कर दो, then here 2 will come, then you subtract. So what we have done, same thing. First multiply this row with 2, means 2 times r1. उसके बाद उसको माइनस करो रो 2 से. So here 2 and minus 1 we have kept as it is, and 1 and 2 over here. But column ये जो रो है first, वो जो that will multiply by 2. So 1 into 2 is 2, 2 into 2 is 4. So here you will be getting r2 minus 2 times r1. So 1 and 2 will be over here. 2 minus 2 is 0, minus 1 minus 4 is minus 5. So here what we have done, that is, ये जो second row है, वो second row को, that second row we have done subtraction with 2 times r1. So first time what we have to do, multiply all the elements of row 1 with 2 and then subtract from row 2. So here is your answer. I hope so this much is clear. So now we are going to see, okay, so right now you can note this, it is a very important, 3 points are there, so you just note it down. And now we are going to see our next topic, that is invertible matrices. It is also a very important topic is there. So here now we are doing the end of a chapter. So I think so in this chapter you might have understood everything. Now our only few topics are left. So now our this topic is invertible matrices. Now when we can say a matrix or a matrix is or are invertible, first of all, if A is a square matrix of order m, and if another square matrix Okay, so now what I am going to do, I am going to explain you this topic. In our this topic, the name of a topic is invertible matrices, or you can also say inverse. Now let us consider that there is one matrix A. It is a square matrix and its order is M. If A is a square matrix of order M, and if another square matrix B is of same order, that is M only, and AB, if you find BA, both answer you get identity matrix, then B is called inverse matrix of A. How? Let us take one example. Let us assume that we have one matrix A is equal to and let us assume our second matrix B is of okay. Now both are square matrix and both are of order. Their both order are also same. Here also 2 by 2. Here also 2 by 2. 2 rows. Here also 2 rows. 2 columns. 2 columns. So 2 by 2 and 2 by 2. So both in both the matrices order are also same. Now what we want to do, first of all let us find AB. So if we are finding AB, multiply first row with first column. So 2 2s are 4, 3 1s are is 3. Then 2 3s are 6, 3 2s are 6, 1 2s are 2, 2 1s are 2, 3 1s are 3. So now what we are getting 1 0 0 1. It is nothing but identity matrix AB. So AB we have got. Now let us find BA. If you will find BA, then also if you calculate, you are going to get the same answer, that is identity matrix, that is also I. So here these both are equal, AB, BA and identity matrix all are same. So we can say that A is equal to B inverse. We can write. Means B is called inverse matrix of A. So this is also a very much important topic in this chapter, which is invertible matrices. So I hope so whatever we have covered today is clear with you. Right now what you are going to do, that is you are going to complete the remaining sums of the previous exercise, and today you are going to revise these both the topics which we have covered, invertible matrices and elementary operations. That 6 operations are there, but 3 operations both with rows and columns. So all of you are going to do the revision of whatever we have covered today, and your homework is that you have to complete the remaining sums of the previous exercise. Okay, so I hope so everything is clear with you all. Thank you very much.